Okay, now let's have an example of the fourth order Runge-Kutta method. Same example just as we use in the Euler's standard or Euler's explicit method and the modified Euler's method. But na lang siya difference no, because instead of evaluating from 0 to 2.5, we are just evaluating here from 0 to 1.5. Same initial condition and same step size. So for the classical fourth order Runge-Kutta method, same lang yapon si x, no? Of course, that is just the old x plus d step size. And then the y plus I, the new y is, of course, this is in this form. You have the old y plus the slope times the step size h. So si slope is 1/6 times quantity k1 plus 2k2 plus 2k3 plus k4. So dali ka siya dumdumon. We just remember that si k1 is the y prime. Actually, puro ni sila y prime. But in the k1, ang imong substitute is the current x and the current y. For the k2, you substitute the x part with this one. The current x will be added with the half of the step size, and the current y will be added with 1/2 of the step size and the k1. This one, k2, similar sila, no? They are just the same in terms of x, and then the y similar, but instead of k1, just k2. So dali lagi ni siya pag masolve nimo si k1, substitute na nimo diri, masolve nimo si k2, substitute nimo diri, then masolve nimo si k3, yan ida po din siya. So dili na siya 1/2 k3. This is just k3. So let's start with our evaluation. So initial point na to, diba, is at 0, 3. Next point will be at x is equal to 0.5. K1, we just substitute, diba, this is just the f of x sub I, y sub I. So ang value ni x, we just substitute it there. And ang value ni y is, yan na. And then you have already our k1 at 3.4. Okay, at k2, this will be the new x. This will be the x part that will be used in k2. And then the y. So we just substitute that in the equation. And then we have this factor in the k2. So this is the k1, this is the k2. And then sa k3, kuhaon lagi gyapon, no? Because kanila ang gikuha, it is because sa k3, ang katong x mo gud nga part is just the same, similar lang. And then we have our k3 nga factor. And lastly, the k4, we just substitute all of this in the equation. And then we have our y at x is equal to 0.5. We just apply this with all the steps. Until katong 1.5, which is the final step as per this current condition. So right now we are going to compare the values calculated in the exact, explicit, modified, and as well the Runge-Kutta method. So kabalo mo gitanong nga dako tog error sa explicit, si modified is much gamay, and if we compare the Runge-Kutta with the fourth order Runge-Kutta with the exact, medyo duol lagi sila. Kung i-round off lang ito taman diri, this will become 4.07. And as well kani po no 4.32. Round off taman diya, that is 4.32. They are almost equal, no, virtually equal. And then if we round off na to taman diri 4.70, this is as well 4.17 if I round off na to up to that part. So with the application of the fourth Runge-Kutta method, mas duol siya sa correct answer, no? Diba? Grabe siya ka kuan. Ang accuracy is much better than the explicit and the modified Euler's method. So again, no, this is the graph showing the Euler's explicit method and the graph showing modified Euler's method or the predictor corrector method. And for the Runge-Kutta method, the fourth or the Runge-Kutta method, they are almost equal, virtually up to the second decimal place. The Runge-Kutta and the exact calculation is equal.